is our STEM research project, Mechanical Advantage and Machine Efficiency in VEX IQ Parts. We are 10.15C, the RoadRunners. Our team consists of Cade, Evan, Bishock, Jonathan, Aksha, and myself, Jackson.
Our project inspiration this year was the VEX IQ 2019 Challenge Next Level. This challenge requires mechanical advantage when attempting to score points. For instance, when we try to stack hubs and hang, we need to use mechanical advantage. We also wanted to understand our robot's mechanical advantage so that we can improve it if needed.
Okay, so for our STEM project, we looked at how we investigated the gears in our robot and the gear ratios, including the levers.
So these are the formulas we use to calculate our data results.
The real mechanical advantage is the output force in newtons divided by the input force in newtons, and this formula will always stay the same.
The ideal mechanical advantage is the effort arm length divided by the resistance arm length. The effort arm length is the length of the arm that we put effort into. The ideal mechanical advantage in gears is the number of teeth on the output gear divided by the number of teeth on the input gear.
Mechanical efficiency is a ratio where you take the real mechanical advantage and divide it by the ideal mechanical advantage, and then finally multiply it by 100.
And this compares how close or efficient the real mechanical advantage is to the ideal mechanical advantage.
In this lever example, this is the effort arm and this is the resistance arm. When measuring, we level the arm out and then pull down the upper side. I'm measuring 6 newtons.
I'm also measuring 6 newtons.
This is a 1-to-1 ratio. For our gear setup, Evan has the input side and I have the output side.
Alright. I'm measuring about 7 newtons.
And I'm measuring about 3.
So these are our lever mechanical advantage results. As you can see, the ideal mechanical advantage is much higher than the real mechanical advantage for levers.
And this is because in an ideal world, there's no friction or there are output factors. But in reality, there was a lot of friction and there's other factors that went into it.
And just like with our lever mechanical advantage, the ideal is far higher than the real mechanical advantage just for gears as well.
So these are our results for machine efficiency in levers and gears. As you can see, the machine efficiency in levers is much higher than there is in gears. And also, lever 1 and gear 1 are outliers compared to the others.
So overall, the machine efficiency in levers is much higher than the machine efficiency in gears. And this is due to because there's more moving parts in a gear system than in a lever system. As you can see, there's one pivot point right here where this goes, but then there's also two pivot points where it goes, but then these gears also rubbing against this piece create more friction, which yet again reduces the machine efficiency.
So one real-world application to mechanical advantage is a crowbar. So if a crowbar shaft is longer, the force you have to apply on the crowbar is less because the distance it travels is also less, which is increasing in torque.
So the applications in VEX IQ this year were applied to all the robots. All the robots use some type of lift or some type of 4-bar lift to pick up hubs and drop hubs and hang. And this was used in all the robots this year, and it was pretty important for them.
This mechanical advantage project really helped us with our robot. As you can see, we installed these levers to help with this year's mechanical advantage and these gear systems. Thank you for your time.